So now we're going to look at what I kind of call factoring covert trinomials, because they're like secrety. They're like, shh, don't tell anyone I'm a trinomial. I don't know why they're ashamed. It's a wonderful occupation. So we were able to solve something that looked like this. Maybe? Yes. Okay. So in previous lectures, we established that they're both a plus, and then 2 and a 5 come up. So we're perfectly content solving these. Now, where we can run into trouble is if we have something that's slightly different. So now what if I had x cubed plus 7x squared plus 10x? You might originally go in here and say, well, this doesn't match the pattern because that's not squared, and the thing in the middle is not squared, or the thing that's squared, so this just can't work, can't do it. You might give up. Whereas on a test, if this was a 1-point problem, this would be, say, a 2-point problem. So it's considered a little bit harder, but not way, way worse, and we can do way, way worse in a minute. Okay. What they want you to recognize whenever you're looking at a problem like this is the first thing that you can do is you can factor in an x. So go ahead and don't make it harder on yourself than you have to. Go ahead and recognize that, hey, all these terms have an x. So if I pull out an x, who's left? And there's this guy. So if I pull an x out of here, I get an x squared. If I pull an x out of here, I get a 7x. If I pull an x out of here, I get a 10. Now remember, the only way that you can factor is if you can pull it out of all the terms. So if I had something that looked like this, I can't pull an x out. Well, I can, but it's going to look more like this, which really isn't helpful. Okay, so I'm talking about problems where you can still pull something out and it still looks beautiful. And by beautiful, I mean mathematically beautiful. So now all I have to do is I can take this here, and I can factor that into its 2 little sections. And it's going to be way easier if you pull that x out first. So we've done this enough now that I know that this particular thing factors out to x plus 2 and x plus 5. Okay, so that's one way that they can make these things look kind of complicated. And those are pretty easy to spot because all the terms will have a variable in them. They might even give you something like, x to the 4th y plus, 7x cubed y plus 10x squared y. And again, you just need to recognize, hey, I could pull I could pull an x squared y out of here. If I pull that out of here, I only have an x squared left. If I pull it out of here, I've got a 7x left, and if I pull it out of here, I've got a 10 left. Okay, so again, I can just factor the second part again, plus 2, and x plus 5. Okay, so beware for those, because they're going to throw those in there just to kind of make you go, ah, and they just want to make sure that you understand it. All right. The other way that they can mess with these is they can make things that still match the pattern, but the pattern's harder to spot. So again, I'm going to write this up here for reference. Now take a look. Now let me write it like this. Let me say x to the 4th plus 7x squared plus 10. Now initially, based on what we just discussed, you might say, well, let me try pulling out an x squared, so I've got this plus that plus I'm not really sure what to put in here. If you really want to know, it's that, and that's not helpful. But I thought you said you could do these. And all right, remember the pattern was something squared plus that same something in the middle. Remember that x to the 4th is really x squared squared. So this actually matches the pattern of something squared times that something again. Something squared, box. Let me try not scribbling on my notes. Box squared times box. So it still meets the basic pattern. And in fact, I could do all kinds of variations on this theme. I could say, x to the 8th plus 7x to the 4th plus 10. Again, this is twice that. That means that it is x to the 4th squared plus 7x to the 4th plus 10. So again, we've got something squared, something in the middle, and going from there. So I could say x to the 6th plus 7x cubed. Again, this number is twice this number. I could say x to the 100 plus 7x to the 50. Again, this number is twice that number, and that's good. That matches our basic pattern. So let me delete some of these guys that are kind of in the way. Oh, I'll leave them there, fine. We'll just pretend we'll work around them. So in this case, instead of having x plus 2 and x plus 5, I'm going to look at the term. See here, that was the x, right? Because the only way to get x was to say x times x. Well, here, there are multiple ways to get the x to the 4th, but we're going to use x squared and x squared. Now, if you don't believe me, multiply it out. First, outer, inner, last. See how it all works? Kind of cool? Yay, woot. Okay. And then here, we're still going to have the plus 2 plus 5 because I haven't changed anything else. The rest of the pattern still matches. But x to the 4th and x to the 4th. Okay? And if I come over here, I still got the plus 2 and the plus 5. So see if you can fill these in on your own. Pause the video. Give it a shot. See if you can do it. If you can't, nobody's going to know. I'm sure not going to know. Unless you make a comment and say, I can't do this. This is awful. And then I'll try to fix it. And I'm sorry. X cubed. X to the 50. Okay. So now that I kind of got your confidence on that, hopefully, maybe, let me show you what else I can do. What if I do this? You might say, well, that's just craziness. Who would do that? Math teachers. And that's because the reason you are learning this is because, theoretically, depending what you're going into, you're going to need to know it. And if you never need to know it again, at least you're learning some logical thinking skills, and it's good for you. It makes you a better person. For realsies, I swear. So again, looking at this, 1/2 is twice that, right? 1/4 times 2. So again, that exponent is twice the other one. Another way to look at it is to say x to the 1/2 squared is x to the, let me try this again, is x to the, am I doing this right? I think I'm doing this right. Sorry, I'm not doing this right. What I meant to say is x to the 1/4, so this term squared is that. Okay? So I've really got x to the 1/4 squared plus 7, x to the 1/4 plus 10. I don't know why I just changed colors. But again, I got the pattern, something squared plus that same something. So again, it's really just as straightforward as plugging it in. If you recognize a pattern, just pretend those are x's. Just solve them like you normally would, and then go in and make this adjustment in after the fact. Okay, but they're going to throw stuff like this at you as well, just to make sure that you're totally comfortable working these kinds of problems.